Live. Very good evening to everyone. So today the topic is going to be the jet streams. I know it's a very important topic for climatology. And in this, we are going to understand the very basic why and how the jet streams are formed. What happens when you start reading the climatology particularly, we try to mug up some concepts. But what I feel that in climatology, you don't require the mugging up, rather you need more of a conceptual knowledge so that you don't have to mug up the certain part of it, and there is no requirement also for mugging up. Reason being, it only demands three things. One, that conceptually you are aware that why jet streams are happening. Second, you should be aware of where they are happening, right? And next, how they are happening. So if you know why, where and how of the jet stream, then I believe that you don't need to mug any other part of it. I think online students can hear me clear and loud. Okay, keep interacting. Keep interacting. Okay. So how jet streams are formed? But before the jet stream, you should know 2-3 things in very clearly. First thing is that the winds are also formed like this, right? So for example, this is the equator. I am drawing a very basic diagram of the climatology in which I'll be just explaining the different sections. So this is the equator. This we call it as equatorial low pressure belt. So before explaining the jet streams, which we call it as, this is a type of a geostrophic wind. Jet streams is a type of a geostrophic wind. But in order to understand, in order to explain this geostrophic wind, I want to explain to you first this part which you call it as equatorial low and subtropical high pressure belt, how the winds blow between this area. Why I am recapitulating this part? Because in order to understand that portion, this portion is also required. Okay. Equatorial low pressure. This is area of your doldrums. Next is your subtropical high pressure. This is your subpolar low pressure, and this is your polar high pressure. I hope you know that there is going to be the mirror image of the same in the southern hemisphere also, right? And apart from that, very basic one, that these two are dynamically induced and polar high and equatorial low pressure belt are thermally induced. They are thermally induced. Now, what do you understand by dynamically induced and thermally induced? What do you mean by these terms? Because these terms look very heavy. When I talk about these terms, dynamically induced, thermally induced, it looks like a scientific term, and I am not able to understand this topic well. Why? Because I am trying to mug it up. But from now on, you don't need to mug it up. Reason being, thermally induced and dynamically induced, you forget these terms first. Just forget these terms. What you have to do, just see the sun. The sun is falling on the northern hemisphere in summers. What will happen? Just see two portion of it. This one, equatorial low pressure, and this one, polar high pressure. Here, the low pressure is building. Reason being because insolation is very high. Why the insolation is very high? Because we know in a torrid zone, which is a torrid zone, you're near to the equator. Your Tropic of Cancer and Tropic of Capricorn, this area is your torrid zone. Here the insolation is going to be high. Because the orientation of the sun, the position of the sun is such in that manner with respect to the earth. But if we see the rays, they are not going well to the polar regions. If the rays are not going well to the polar regions, what will happen? This will not have enough heat. And since it will not have enough heat, what will happen? Automatically, very high pressure. What is the golden rule that one has to understand? When the temperature is low, what is going to be there? High pressure. But ये rule थोड़ा सा change होगा कहाँ पे? सब ट्रॉपिकल में. बट सब ट्रॉपिकल में तो टेम्परेचर इतना कम होता नहीं है, तो यहाँ पे हाई प्रेशर कैसे है? यू जस्ट फॉरगेट दैट फॉर टाइम बीइंग. क्यों? बिकॉज अभी हम सिर्फ थर्मली इंड्यूस्ड की बात कर रहे हैं, राइट? सो दिस इज नॉट फिटिंग इन हियर. तो इसका मतलब ये हुआ, आई शुड चेंज माई डेफिनेशन इन सच अ वे विच फिट्स यूनिवर्सली. एंड हाउ माई डेफिनेशन फिट्स यूनिवर्सली? इफ आई से if the air is descending at a place, so shall I change my statement? How I have to define air pressure? High pressure. If the air descends here at this zone, I call it as high pressure zone. If the air ascends means going upwards, I call it as low pressure. If it descends, high pressure. If it's ascend, low pressure. Please write down everyone in your notebook. Write down right now. This is one of the topic that you have to understand. These are some of the universal rules that you have to keep it very, very neatly with you. Why? Reason being because when you will be understanding this concept, you require these rules. So whenever in any area, write down, in any area, in the case of descending of the air, the region of high pressure will be created. The region of high pressure will be created, while in the case of region, where the air ascends, there will be the creation of low pressure. There will be the creation of low pressure. There will be the creation of low pressure. Okay. Now, apart from that, what do you need to understand? These are two dynamically induced. These two are your dynamically induced. Dynamically induced means these are not the high pressure by the virtue of the fact कि यहाँ पर sunlight जो है वो आपका नहीं पड़ रहा है. This is because there is a low pressure here, right? And if I talk about the ascending, जब air mass ऊपर जा रहा है, when the air is flowing above, what will happen? They reduce what? The temperature. As you know, in troposphere, as the air rises up, the temperature of the air reduces. Why? Because there will be a lapse rate. Adiabatically lapse rate they will experience, right? So when the air is moving upwards, there will be decrease of temperature. For every 1 kilometer, the temperature will decrease by 6 degrees. Right? This is an average. It can increase also and it can decrease also. depending upon different circumstances. But for now, you have to just understand there will be a decrease of temperature as it goes up. Understand it as if it does not have a fuel, right? And since it does not have a fuel, what will happen? It has to land down. Where it will land down? It will land down here at subtropical high pressure belt. But I am not calling it as high pressure now. Why? Because I am understanding it for now that whether it has to be called a high pressure or not. I'm no one to tell or declare this a high pressure for now. Forget about this. Forget about this whether it's a high pressure or not. Let's figure it out on your own, right? As the air is ascending from this place and it is going upward in the atmosphere, the temperature of the air decreases. Why it decreases in troposphere? The temperature decreases for every kilometer by 6 degrees Celsius, and the temperature decreases. What will happen? It will not have enough energy to go above, right? When the air ascends, जब वो heat up हो जाती है, but when the energy is not that much, यहाँ पे heat up ही नहीं होगी, तो what will happen? It has to descend at this place, and this place is known as your high pressure zone, and this latitude is 30 to 35, which you call it as subtropical region. So therefore, I am writing subtropical high pressure. Subtropical high pressure. This area is also known as horse latitude. We call this subtropical high pressure belt with the name of horse latitude. Clear everyone? Shall I move? Right? Online students, if you have any doubt, take 2 minutes and let me know. Right? Okay. Now talking about subpolar low pressure, right? See, this subpolar low pressure is the area of temperate. This is a temperate region basically. So you will ask me, ma'am, the temperature is low here, right? The temperature is low, very low. So आपने तो ये बोला था कि low. So what did I say? Universally, what should be the definition of the pressure? You have to understand the pressure through descending or ascending. So here what is happening? See, this is a frigid zone. Here the temperature is not, the solar radiation is not going very well. So what will happen? This is automatically a high pressure region. The relativity, we talk about relativity between the two belts, right? This is extremely cold. So definitely the air descends over here, right? And from where the air mass is coming? From here, right? So when it is coming from here, what will happen? It rises up and descends here. And where the air ascends, wherever the air ascends, we call it as a low pressure region. We call it as a low pressure region, right? Clear everyone? But now I have to explain what? I have to explain another thing which you call it as how the winds are blowing from different belts, right? कैसे belts different belts से क्या हो रही है? Winds जो हो रही है different belts से move कर रही है, right? As we have introduced, this is a region of doldrums. This is equatorial low pressure belt. This is subtropical high pressure. This is subpolar low, and this is polar high. Write down a very important universal rule. Write down. Wind always blow from high pressure to low pressure. Winds always blow from high pressure to low pressure. Winds always blow from high pressure to low pressure. So winds are blowing from here, from high pressure to low, right? In the northern hemisphere, it will blow from high to low. So when it is blowing from here, what will happen? The direction of the wind is not going to be like this. Please see it here. I'm zooming it at this place. The wind direction is like this, from high pressure to low pressure. It is not going to be like this. The direction is not going to be like this, right? Why? It will be deflected towards right. Now you will ask, ma'am, deflected toward right or left? Because what we can see is left. But I am talking about the direction. In actual direction I am standing, okay? Because the arrow is downward. So I have to place my hand like this, from high pressure to low pressure, right? In the northern hemisphere, there is a rule that the wind always blow from high pressure to low. This is a universal rule. But apart from that, the wind is deflected towards right. Always right in the northern hemisphere. Always right. The Coriolis force acts towards right. Right? This is a rule that you have to remember. So what will happen if I'm standing in this direction and the wind is blowing like this? It is not going to go straight like this. It will be deflected like this, in this direction, right? Deflected towards right. So how the position should be? Like this. Therefore, the winds are blowing in this direction. Since the wind are originating from east, this is the east direction, almost east, right? So you call this as easterly winds or trade winds. These are known as trade winds. Similar phenomena is also applied in the southern hemisphere. Xeroscopy. No changes, same. But this time only one change is there. I have to stand in this direction. Where is my arrow going? Because this is a high pressure, this is the low pressure in southern hemisphere. This is how you have to place your hand. And I told you that in northern and southern hemisphere there is one difference. In southern hemisphere, the winds blow, or in southern hemisphere the Coriolis force act towards left. They deflect the winds towards left. Okay, it's like this. This is the hand I have to take, right? And I have to deflect. You take any hand, right? And you deflect towards left. Same phenomena you can apply in all the belts which are present here, but only one thing you have to be careful about the directions. Okay, very careful about the directions, because once the direction changes, everything gets changed. These are called trade winds, or you call them easterlies, right? Next, this is subtropical high, this is subpolar low. Winds blow from, please, you tell me, winds blow from? Excellent, high pressure to low pressure. So where should my wind go? In a wind, which direction? In upward direction, right? It will blow like this. Why like this? I am placing my hand like this. See the arrow first. This is the arrow. So I have to place my hand towards arrow. Right? First I'll see which is a high, which is low. This is high, this is low. I'll draw like high to low. And I have to place in this direction. I know one golden rule that the wind always blow in the right direction in northern hemisphere. So I'll blow my wind like this. Okay? By the fact that it is originating from the west. So they are almost a west direction. So these are known as western. Right? Similarly, we will draw it here. Now, high to low, and similarly here. See, the wind patterns here and here are same. Can you see? Can you see the wind patterns here also and here also? They are same, right? So, in order to distinguish, you call it as polar easterlies. These are what? Trade winds or tropical easterlies, but those are polar easterlies. Online students, if you have any doubt, please ask. Everyone. Harshika, Rakshat, Sulbi, Vanchika, Suraj, please, everyone, anyone, if you have any doubt, please ask me. Rakshat is saying clear, okay. Yes, I've not drawn it fully actually. It has to be like this. All right. Shall we move to our next topic? Right? Okay, the topic which I will actually explain today is geostrophic winds. See, your geostrophic winds are not same winds as your normal winds which I have shown. Okay, the winds which I have shown right now in the previous direction, in the previous diagram, it is not same. Okay, ये same नहीं है. So how are they? They are different. What are these geostrophic winds? These geostrophic winds are moving in the upper atmosphere. They always move in the upper atmosphere. When I talk about these geostrophic winds, the first thing you have to understand that they blow in upper troposphere, upper part of troposphere, or lower part of stratosphere. Lower part of stratosphere. What is the length of the troposphere? It is 0 to 13 kilometers, right? On an average. So this winds blow between the range of 6 to 12 or 6 to 13, right? And also you will find it in the lower part of stratosphere. The troposphere comes first, then comes the stratosphere. So ideally, if I want to show you how they look, so this is your troposphere till here. So winds will be blowing from this direction, right? In this part particular. This is your stratosphere. Please draw this. What are the features of these winds? These winds are long, meandering. These winds are long, meandering, circumpolar winds. Just focus. I'll make you write all of that. Don't worry, right? They are long, they are meandering, and circumpolar winds. So where they are? What do you mean by long? The length of the wind is quite sufficient, right? To call it as long. Meandering winds, the direction of the wind is always changing. It's following a path like this. And circumpolar means that it will blow near to the poles as well. When I talk about poles, I'm talking about both the poles. Now write down the basic definition. jet streams are long, narrow. Jet streams are long, narrow. Jet streams are long, narrow, high speed, meandering, high speed, meandering, circumpolar winds, circumpolar winds. Circumpolar winds. Now, why are they high speed? That is my question. Why are they very, very high speed? Can anybody give me the answer of this, online students? The window is open for you if you want to answer this question, that why the high speed is associated with geostrophic winds, or you call jet stream also a type of a geostrophic wind. So why the jet streams are having a very, very high speed? Yes, Uday. Why it is having a high speed? Otherwise also. Yes, that is also a wonderful point that he has said. In winter season, that is also we have to see that in summer season, the speed of the wind decreases, right? And in winters it increases. We'll discuss about that too. But first I'm asking a very general question to everyone, that why the speed of the jet streams is associated with high speed, why it is having a high speed. So I'll give you one hint, that it is at a very, very high altitude. I mean 6 to 12 kilometer if you are having a jet streams flowing. So what is not there? It is flowing at between 6 to 12 kilometer. See, in the upper troposphere, what happens? The friction experienced by winds is quite minimal. And since the speed can only be stopped, what is the friction? For example, I'm moving in this direction, so opposite direction. Every action is an equal reaction, right? So if I'm moving in this direction, there is a force which is stopping me from here, going from this point to this point. There is a counter force, right? But what happens as we go above in the troposphere, the speed increases because the frictional force which is coming from that side reduces. The frictional force reduces. And since the frictional force reduces, what will happen? The Coriolis force which is acting, how the winds are blowing? In all the zones, all the pressure belts, how I have shown the winds to be blowing like this or like this, right? This kind of diagram I have shown to you in the previous slides, right? But what will happen in the upper atmosphere, in the troposphere? The frictional force working against it will be very, very minimal. So what will happen? Instead of blowing like this, it will blow in this direction. It will blow in this direction. So what will happen? The geostrophic wind or your jet streams is a type of that only. So I'll just write jet streams. Will blow at a high speed. They will blow at a very high speed. Done? Are you getting the point? Or should I explain again? Online students. Did you get? Okay. So as you're going up, I'll explain again. As you're going up, what is happening? Frictional force. Just understand this. The frictional force is reducing. And when the frictional force is reducing, what will happen? The speed will increase. And as the speed increase, what happens? We call it as that the jet streams are having extremely high speed. And this speed is also dependent on another factor, which we call it as pressure gradient. Pressure gradient is nothing but difference in the high pressure and low pressure. We have discussed this yesterday, right? When we have the difference between high pressure and low pressure, the more the difference is, we call this as pressure gradient. And more the difference is, the higher will be the speed. More the difference between high pressure and low pressure, more will be the velocity. Right? First write down, I'll repeat all of it again. Don't worry. Okay? Right? So what will happen? Just write. Online students, please write. I'll repeat this point again. Written? This one. Right? Done? Everyone? Alright. I'll please repeat each and every topic related to jet stream again. So if you have any doubt, please ask me again. I hope that you've written everything. Shall I move to the previous slide? If you have not written, online students, please raise your hands. Or you can clearly use your chat box. Anshika, Subhi, Rakshika, Rakshat. Done. Alright. Okay. So what are these geostrophic winds? Geostrophic winds or just these winds are blowing in which part? They are blowing in the upper troposphere, or I can say in the lower stratosphere. So I have drew the diagram also of that. This is the troposphere. What is the length? We have done this part, right? In the layers of atmosphere, we have different layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. Remembering, right? So this winds only blow in this part. This is what the first half, the first part of it is known as troposphere. So the winds blow, that's why known as what? Upper circulatory winds. Why upper? Because they are blowing in the upper atmosphere of troposphere, upper part of the troposphere, right? So they are blowing here. So these are varying from 6, or you can say, to be precise, 7.5 to 14 kilometer, right? And then they also go in stratosphere. But where in stratosphere particularly? In the lower portion of stratosphere. Lower portion, right? Since they go in the lower portion of stratosphere and upper portion of troposphere, they are known as upper circulatory winds. What are the features that we have discussed? This is long, narrow, high speed, meandering, circumpolar winds, blowing in both the hemisphere, right? It is not that it's blowing in the northern hemisphere only, not southern, southern only, not northern. They are blowing in both the hemispheres, right? Now, what is happening? Because the frictional force present in the upper atmosphere is less. The frictional force in the upper atmosphere present is less. Reason being, it will be deflected like this. Because why it will be deflected? There is only one reason for the deflection. What is that? Coriolis force. What is Coriolis force is doing to the wind? It is deflecting. Please understand, it's a very conceptually important thing that the Coriolis force just deflects the speed, that just deflects the direction of the wind. It does not increase or decrease the speed of the wind. Right? Please write down this important point, that Coriolis force is responsible for only deflecting the wind direction, only deflecting the winds in different directions, and they are not associated with change in the speed of winds. They are not associated with change in the speed of winds. They are not associated with change in the speed of winds, right? So velocity or the speed of the wind, they are not related to Coriolis force. How Coriolis force is related? They only deflect. There was a question in Prelims 2024 of Coriolis force. What it was asking? A very simple question. In one of the options, they were asking where the Coriolis force acts maximum. Where the Coriolis strength is maximum, whether at the poles or at the equator. So what was the answer? At the poles. Write down this point. Coriolis force acts maximum at poles. Coriolis force acts maximum at poles and minimum at equator. Minimum at equator. Minimum at equator. Okay. What is the reason behind it? I will explain you after explaining this part, right? Otherwise, we'll switch between the topics. I just want to continue with the topic, right? So why the speed is maximum at the poles, why it is minimum, we'll also do it with the reason, right? You don't have to mug up it like that. क्यों होता है ऐसा, that is also we will discuss. So, online students, are you with me? ठीक है, so this is what, तो प्रेशर अब क्या हो रहा है यहाँ पे, what I told you, ठीक है, we have done the characteristics. Apart from that, what we have to do, I was telling you the direction. Now direction, most of the time it is going to be from west to east of jet streams. Most of the time it is going to be west to east, but in some of the cases it's also going to be east to west. For example, your tropical easterly jet streams, which are majorly responsible for bringing monsoon in the interior of the India, they are exception. They are falling under the exception. Okay? Okay. So moving back to this topic. So the winds are blowing and they are deflected like this, right? Because of Coriolis force, and they blow like this in this direction. Okay. Now it is clear, Surbhi? Good. Now we will do the characteristics of jet streams. Come to the topic, characteristics of jet stream. Right on the first point, they generally move from west to east. They generally, I'm using the word generally, please underline this word generally. By because there are some exceptions where they also move from east to west, which is tropical easterly jet streams, right? They generally move from west to east. But explanation was remaining now for the online students, right? In a narrow belt of few thousand kilometers. In a narrow belt of few thousand kilometers. Write down their circulation path or their trajectory. Their circulation path or trajectory. What do you mean by trajectory? Direction or path. Trajectory means basically path. So what path they are following? So their path, or you can also call it as trajectory, is wavy. Or the better word you want to use is meandering. Meandering. Next point. Third point. When the pressure gradient is high. Gradients means difference. Bracket में write down different. Or if you want to explain this part, you can write down pressure gradient is high pressure minus low pressure and put it in a box. And now pressure gradient is, or difference is high, the speed of the jet stream is also going to be high, or velocity of the jet stream is also going to be high. And when the pressure gradient is going to be low, the speed of jet streams is also going to be. See what happens when you try to do this climatology chapter or jet stream. These are very heavy topics if you try understand it through books or any other PDF for that matter, because the language which is being used there is very, very heavy, very, very typical scientific language has been used. So in order to clear the concepts, you won't need the books. What do you need? You need the proper guidance, some direction by any person who can simplify this very, very important and very complex and complicated topics for you, especially when it comes to oceanography, climatology, which actually requires a good detailed conceptual clarity. Right? These are the topics. If you start dealing it with the books or any other matter, what will happen? You will just fall into that loop and you will never understand. Okay? Right on the third point. This was the third point, right? Right on the fourth point. In summer season, the speed of the jet stream is low as compared to winter season, right? What is the maximum wind velocity? Write down 480. Maximum wind velocity is 480 kilometer per hour. Write down kilometer per hour. Done? Yep. All right. Now we'll do the types of jet streams. How many types of jet streams we have? This is the next topic, subtopic of jet streams. Types of jet streams, and then we'll do where they are and what are its type. We'll do it in detail. So what are the types of jet streams that we have? The first one is polar front jet streams. The first one is polar front jet streams. Then you have subtropical westerly jet stream. Then tropical easterly jet streams. We'll write about each one of them. We are just building the what? The map first, right? We are just trying to branch it out and then we'll discuss about each one of it. Tropical night jet stream, write down. Sorry, polar night jet stream. And then last one, local jet stream. Right? So what is this polar front jet streams? Where they are occurring These jet streams form above the convergence zone between polar cold air masses and tropical warm air masses. So what is the latitude? At what latitude they are forming? They are forming between 40° to 60°. Polar front jet streams falling between 40° to 60°. And how they have been formed? Because of contrasting air masses. What are the contrasting air masses? Contrasting air masses means when you have the cold air mass and the hot air mass. Contrast means what? What do you mean by contrast? Different, right? So there are two contrasting air masses. What two contrasting air masses that we have? Cold and hot. Can you tell me how the two cold and hot or warm contrasting air masses which are present in that area? Better you write warm. Can you tell me how cold and warm air masses are present there? Very good. So what is happening? Convergence, right? So, but this is not the case. I'm talking about this area particularly. Please have a look at the diagram. Please look here. Right? So what will happen here? Ascending, and it is descending, right? Ascending and descending there, right? Tell me the hot air mass and the cold air mass here. This is warm, and this is cold. Similarly, what will happen here? This is yes. So what kind of masses that you are having? You are having contrasting mass. So wind blows from what? Cold to warm, right? Geostrophic winds which are being blown are not blown because of this. ये आपकी different winds हैं, ठीक है? ये blow कर रही है because of contrasting air mass, cold and warm here, right? When they are ascending, that becomes warm. Always remember, ascending means warm, descending means cold. So this warm air, the wind blows from cold to warm, right? So what is this? There will be a formation of jet streams, right? Write down. Write down. In a polar front jet streams, jet streams form above the convergence zone in a polar, write down, in a polar front jet streams form above the convergence zone between polar cold air masses and warm air masses. Between polar cold air masses and warm air masses, comma, typically at the latitudes, typically at the latitudes 40° to 60 degree, 40 degree to 60 degree. They are irregular, they are irregular and strongly influence the wind patterns. They are irregular and strongly influence the wind patterns, right? Now write down about subtropical westerly jet stream. Second, subtropical westerly jet stream. So these winds are blowing from, these winds are coming from west, right? West direction or what? That's why westerly, west to east. This wind has a too much of role to play in the Indian monsoon as well. So especially when your winters will come, right? This wind has a big role to play, which is called as subtropical westerly jet streams, right? They are coming from where? Mediterranean Sea. Where is Mediterranean Sea? South of Europe and north of Africa. Okay. Okay. So these are coming from that area, subtropical westerly. What is the subtropical area? Between the latitudes of, we are talking about nearly 35 degrees. Okay. Right. The shift of this subtropical jet streams happen. Abhi, what we have not seen, we have not seen the different changing of the belts. जब शिफ्ट होता है that we have not seen for now, but आपको क्या करना है, when you will understand monsoons, the role of the subtropical jet stream is going to be huge. So you have to just remember that. Okay, दो आपकी जो स्ट्रीम्स है, जेट स्ट्रीम्स है, उनका बहुत बड़ा रोल है. एक है आपका सब ट्रॉपिकल वेस्टर्ली जेट स्ट्रीम्स एंड अनदर वन इज ट्रॉपिकल ईस्टर्ली जेट स्ट्रीम्स, right? Easterly means coming from the east. Everyone is clear on that, right? Next, it is located in upper troposphere. Write down. It is located in upper troposphere, north of subtropical, north of subtropical high pressure belt, north of subtropical high pressure belt. In the bracket write down 35 degree north, 35 degree south, 35 degree north and 35 degree south. Full stop. These are more continuous. These jet streams are more continuous and regular in nature. One more thing I would like to add, please do not stick to that 35 means 35 only. They can vary also, right? It can also between 30 to 37. This is just an average latitude which I have given it to you, right? When we'll do the ICZ, so then we'll understand that how it changes, but we are not doing that that topic right now. So you have to just understand that this is 35 degree. It can also vary between 30 to 35 degree north and 30 to 35 degree south. Okay. Please write down. Next point, these winds have a role to play in Indian climate. These winds have role to play in Indian climate. Or you can write down, they influence mid latitudes weather system. Mid-latitude weather system, right? Online students, if you have to ask any doubt, just go through that and let me know. Clear? You? Lot of question comes directly. They ask in UPSC means. There was a question on air masses also that we'll do, right? They ask about this Rossby waves. So see, one thing I just forgot to mention, a meandering and wavy path that they take, that is known as Rossby waves. Okay, have you written that? Okay. So I have to also mention this point today because I think I have not mentioned it today in my today's class, that when the meandering and wavy path takes place, we called it this as Rossby waves. So direct question comes, explain Rossby waves, what are these impacts, how they are changing, how it impacts the weather system. So very generalized question comes, especially when you talk about the climate, your world climate when you talk about. So these questions are very, very important, right? And when they come, you have to present them in a very nice manner, right? Along with the diagrams, etc. So when you're conceptually very strong, then only you will be able to write very well that 8-minute or 9-minute answer. No, they provide that booklet. Yes, pen paper will be provided. There are certain number of sheets which are present there, and you have to write. Enough number of sheets are there. You don't have to ask for extras. Don't worry. Yes, obviously you have to stick to the word limit. Otherwise, what will happen? Your questions you won't be able to complete on time, right? And you have good questions. Like you have to complete it in 3 hours only. Like that, you have to stick to the timelines. Okay. So for one question, you have to give only 7 to 9 minutes. Only you have to stick to 7 to 8 minutes. 8 minutes is good, right? If you exceed in one question, that means you're reducing the time for another question that you will get in your mains, right? Mhm. So that depends how strong is your subject is, but most of the time it's less, like half. Most of the time it's half. Huh. Yes, like between 100 to 120, 140. For 40 is also very good. Yes. Now for different subjects I'm talking. For GS1 it's different, for GS3 it's different. Depending upon which GS is your strength. For example, some people they have GS1 as their strength. GS3 is not their strength. Some people score very well in GS3, right? So this is how you have to see. You have to identify your weaknesses and strength, and then you have to work on that. In geography, the role of this diagram is huge. The more you practice the diagram, the more you will understand that how you have to carry it forward, right? Okay. So next, write down tropical easterly jet streams. Have you written this? Write down tropical easterly jet stream. Write down formed in the upper troposphere during summer. Formed in upper troposphere during summer. Particularly over India and Africa. Particularly over India and Africa. Shall I write? particularly over India and Africa. How they have been formed? These winds are formed due to intense heating of Tibetan Plateau intense heating of Tibetan Plateau. First write down, then I'll explain it to you. Tibetan Plateau. What will happen here? See, India, right? And here is your Tibet. Now in the month of June, or you can call it to be precisely May, between May and June, the sun is directly over the head, right? And is heating which area? It is heating this part, right? It is heating this part. So this becomes the area of low pressure. Why? Because this area, the Tibetan Plateaus, is heated up, right? So what will happen? It will attract horizontal winds. From where? From this side. Why? Because we are talking about the relativity in the temperature. I'm not saying the temperature has to be very, very low in order to attract the winds, but this will attract the wind. Reason being because it is extremely heated. How is the Tibet Plateau? It's very big, elevated. Have you seen the Tibet Plateau? It is a elevated landform, right? An intense heating will happen in the month of May and June, and that it will happen uninterrupted. What will happen? It creates a region of low pressure, and when it creates a region of low pressure, the wind system will attract what? Winds from the, yes. So there will be a formation of easterly, tropical easterly jet stream. There will be a formation of tropical easterly jet streams. Because of this jet streams, what will happen? The winds. So how the monsoon is coming? So you don't have to club that topic here. I'm just explaining that since you have not done monsoons till now, so do not get confused. So just understand that they have the huge role to play in bringing the monsoon in the interior of the Indian subcontinent. Reason being because the winds will go like that. Which branch? Bay of Bengal, right? Because this is going in this direction, it also forces this winds to move in the interior of the earth, interior of the Indian subcontinent. And when it forces it, it brings or pours down the what? It's responsible for bringing the rainfall. It's responsible for bringing the monsoons in the interior. This is one part of it, which is responsible. Obviously, we have Arabian branch also with us. Okay, right? Getting the point, right? So, though you have not done the monsoons yet, we will do that. But you can write down the tropical easterly jet streams. Write down tropical easterly jet streams are responsible for bringing monsoon or slash rainfall in the interior part of Indian subcontinent, or simply write down India. Right? Now the very important one, the second last one, we have moved to polar night jet stream. What is the first description that we have to do about the polar night jet stream? That it is what? It is stratospheric. Where is stratosphere? Yes. So it is that you have to remember that it is stratospheric. So what is the position of it? High. So what is the length of the stratosphere first of all? Very good, right? So what will happen here? Stratospheric subpolar jet streams, they develop during winter season due to steep temperature gradient in stratosphere around the pole, right? So write down, also known as stratospheric subpolar jet streams. Subpolar jet streams. They develop during winter season. They develop during winter season due to steep. Due to steep. Steep means quite, काफी. Steep temperature gradient. Have you seen the application of jet streams ever? What is the application of jet streams? Have you seen the airplane, how they are moving? At what height they move? At what height the pilot kick the aircraft? Yes, troposphere and stratospheres also, right? Do they get stuck in the jet stream sometimes? So what will happen if they are in the same direction? Online students, are you getting my question? What I am trying to ask? So I am asking that at what height the pilot takes their aircraft. So this is the troposphere. This is a flight. This is stratosphere. This is a jet stream. So how safe for them is to fly in the jet streams? These winds are also flowing at the same direction, no? And the pilot is also moving their aircraft in the same direction, at the same height. They will. Why? Yes. If they are in the same direction, that will increase the speed. And if they are in opposite direction, they decrease the speed, right? So what we are trying to say, online students, that this is the speed of this is the direction of the speed of the geostrophic winds, right, or the jet streams. So what will happen? The pilot is also, aircraft, your airplane is also moving in the same direction as your wind. So what will happen? It will boost the speed. It will help the airplane to move in this direction. So your duration of your journey get reduced. और अगर different direction में नहीं होगा तो क्या होगा? Oppose करेगा तो duration will increase. Getting the point? But most of the time it is better to not go in the jet streams because sometimes they also become detrimental. बहुत बार ऐसा हुआ है कि jet streams में फंस के they are unable to get out of it because the wind speed is too high. Unless the pilot is too trained or he has too much of experience of flowing or getting his aircraft in the jet streams, better to not take it most of the time. But unless he is not experienced well, right? So these are the application of jet stream, right? Okay. Now the last one, not a very important one, which is a local jet streams. Okay, why they are being formed? You have to just don't write anything in that. They are formed due to specific local thermal and dynamic condition, right? Because of the local change in the thermal and dynamic conditions, these jet streams are formed. For example, write down the example under it, Somali jet streams. Just write down this one example of it, Somali jet streams. Now we are moving towards the last leg of the topic, which is significance of jet streams? Why we are reading the jet stream? What is the significance of jet stream? Why we are reading them? Why? The very first one is climate. So how they influence the climate? We have just seen that how subtropical westerly jet streams and tropical easterly jet stream influence the climate, weather patterns of different area. And when they influence the weather pattern of different area, what happens? They play a huge role, right? For example, they can transport the weather system across the world. Do I need to explain this point further? Right on the second, this is also responsible for ozone layer depletion. How they are responsible for ozone layer depletion? Can you just explain me? This is extremely important and it has been in the current affairs as well, lot of times. Can you tell me how they are responsible for ozone layer depletion? First of all, what are ozones? O3, right? Where they are present? In stratosphere. They are present in stratosphere. So what is going upwards that it is impacting ozone? What is going upwards with air masses? What is going upwards? क्या जा रहा है आपका यहाँ पे ऊपर? जेट स्ट्रीम्स ऊपर जा रही हैं तो क्या लेके जा रही हैं? एयर मासेस, एयर ही लेके जा रही है कहाँ की? ट्रोपोस्फेयर की, राइट? क्या है उसमें? व्हाट इज देयर इन दैट? harmful substances. What kind of harmful substances? Such as HCFC, CFC, HCFC and VR, bromine. What they will do? They are responsible for pollution. How they will deplete the ozone layer here? So what happens when CFC, HCFC, which are used in your lot of refrigerants, right? You use it in your air conditioners, right? There have been an amendment also, lot of environmental conventions which are present to eradicate this. जब ये HCFC and CFC they mix in the air and they are transported in stratosphere. Stratosphere में क्या है? Ozone layer है. This ozone layer protects us from harmful ultraviolet rays. Okay, and this O3. So what will happen when this chlorine, bromine, they all will go here. They react with O3. They try to break O3. They react with them, and when they will react with them, it produces O2 plus O. Free radical, free O. Right? Again, they will do the reaction with O3. So basically, your O3 is getting depleted. अगर आप किसी चीज से रिएक्ट कर रहे हैं और उसको ब्रेक कर रहे हैं, O2 O3, O2 नहीं कर पाएगा हमें सेव. Only O3 can save us. And we will try to deplete O3 by reacting with it. What will happen? क्या होगा फिर? We won't have any layer there above the stratosphere which will protect us from the harmful UV rays. Because they do the reaction. This bromine, chlorine, they do the reaction with O3. Are you getting the point? Right? तो ये कैसे जा रहा है ऊपर? जो आपकी winds जा रही हैं ऊपर, right? Jet streams की बात हो रही है. The jet streams are having what? They are carrying the harmful pollutants with them. The harmful pollutants when they are carrying up, अब वो कैसे हमें reduce करना होगा? जब हम यहाँ पे stability लेकर आएंगे. Because jet streams को नहीं पता है whether they are harmful or not. Jet stream is doing their own work. It is a human. It is us who has created this havoc by using some harmful substances which do what? They does the chain reaction. They do the what? They do reaction with the O3 and try to deplete them. ठीक है? Right? So write down. Jet streams may transport ozone depleting substances.
हेलो भाई
Jet
ले लेना
streams
यार, मैं
may
अपना घर ले जा रहा हूँ। हेलो,
Can I write on another slide so that it is clearly visible? Jet streams transport harmful substances, harmful ozone depleting substances such as CFC, HCFC in the atmosphere. These substances react with ozone O3 and break it O2 and O further degradation of ozone layer. Please write down this. Okay. Online students, have you written? Write down one application of jet streams. This is the last one. If the airplane, we can write down the heading transport. Write down. If the airplane is moving in the same direction of jet streams, it helps to reduce the speed. Sorry, it increases the speed. It helps to increase the speed of airplane, thus reducing the dependency on I don't mean to say that if you don't require fuel for airplanes. I'm just saying that too much of air fuel. I should change the statement that thus fuel consumption will be less. Right? Thus fuel consumption would be less. This is how you have to understand this. Okay. All right. So we have done with the topic. So if you have any doubt, all the online students as well as you, all of you, if you have any doubt, just let me know. So what we have done, can we just revise it? Because we have done so much today. We have covered whole of jet streams we have done. We have seen this chart also. So first we were doing what? We were doing the surface winds, which are going from different pressure belts, right? We've done equatorial low and high and then high, right? And low, high, right? And I've told how they are moving. So what is the use? What is one thing that universal law that I've told you? Winds always blow from high pressure to low pressure. And why they are deflecting? They are deflecting because of the Coriolis force. What is the northern hemisphere? The Coriolis force acts in the right hand side. You use this, and I have told you how you have to use this direction thing, right? And apart from that, we have done in detail the geostrophic winds and also the jet streams, how they are blowing in the upper troposphere and the lower part of stratosphere. They are high speed, they are meandering, they are circumpolar, all the characteristics that we have understood in detail. Now because the friction is very less, what will happen? The speed of the wind is very high, right? And because of the Coriolis force, they are moving in this direction, not like this, okay? Because frictional force is less, so Coriolis force is acting in a very nice direction. It's acting like this, right? And it is moving in this direction. So what will happen in the upper troposphere? The frictional experience by the wind is quite minimal. Most of the time they are blowing from west to east, right? But there are some exceptions that we have discussed. Apart from that, when the pressure gradient, you mean the difference between the high pressure and low pressure is quite high. So what will happen? The speed of the wind is also going to be very high. And if the pressure gradient is less, that means the high difference between high pressure and low pressure is less. What will happen? The speed will be low, right? Summer season में कैसा होता है speed? Low, ज़्यादा नहीं होता. Winter में काफी होता है. Why? Because temperature gradient बहुत ज़्यादा होता है. Difference जो होता है different area का वो बहुत ज्यादा होता है. जैसे जो आपका अपर लेयर है, जो पोलर रीजन है, वो फ्रिजिड हो जाते हैं एज कम्पेयर टू टेम्परेट. तो डिफरेंस ज्यादा हो जाता है, तो फिर स्पीड भी इट इंक्रीजेस, राइट? Next we have discussed characteristics, and then we have had a look at the types of jet streams. What are they? They are polar front, subtropical westerly, this tropical easterly, polar night jet streams, and local, right? And then we have done the significance of jet streams. I hope it's clear to you, right? If you have any doubt, anything, just practice the questions on the basis of jet streams and also practice the mains question on this, right? And try to understand, and you'll bring the topics to that question PYQ to me and let me know how much you have understood. All right? Thank you. Thank you so much, class. Online students, this is for you as well. Thank you.